All right, we're now going to do one more of these. We're going to use the limit definition, but it's in our definite integral notation, which is our fancy notation from last year. So let's see if we can figure this out based on what we know. So we know that this is our lower bound and this is our upper bound. That's going to be our function in there. So I'm going to find my width by taking my upper bound minus my lower bound over n, which is going to be 3 over n. Then I'm going to find my height by, let's see, it says that it is starting at -2 this time. So I'm going to take my function, I'm going to put -2 in first, plus my height, or sorry, my width times I. I'm going to take that and substitute it into that function. So I've got 2 times -2 plus 3n times I. And if I solve that a little bit, I get -4 plus 6n times I. All right, now I'm going to take this, and in order to find the area of my rectangles, I take the width times the height. And then I'm going to add all of those rectangles up. So I equals 1. Ooh, not 1 this time. Oh, yes, 1. Still 1. Okay. 1 to n, because it's an index number, not our bounds. And then we're going to take the limit of all of those rectangles as n goes to infinity. All right, so let's see if we can fix this up a bit. It looks like I'm looking at the work here. If I wanted to, I'm going to go ahead and take this guy out front. So I've got the limit as n approaches infinity of 3 over n. The sum is I equals 1 to n. And then I'm going to make a common denominator in here of n. So that's going to make I have to multiply that one by n plus 6i. What happened? Oh, I know what I've got to do next. Okay. So I'm going to end up taking this n out front as well. So I have the limit as n approaches infinity of 3 over n squared. The sum as I equals 1 to n of -4n plus 6i. Okay, we're going to do our substitution in step now. The front part does not change. It's the same as it was before. Now, remember a constant, because the n is acting like a constant, that goes to the end for the summation is the constant times n. So this is going to be -4n squared. And then we've got plus 6, and for I, we get to substitute in n times n plus 1 over 2. I am going to do a little bit of simplifying, and I'm going to get it over a common denominator. So the limit as n approaches infinity of 3 over n squared. My common denominator is going to be 2, which means I need to multiply that by 2, which would give me -8n squared. And then when I distribute this through, I get 6n squared plus 6. So we are super concerned about our coefficients on the n squared. So I'm going to go ahead and simplify. I'm not going to do anything super tricky this time like I was doing before, since this is pretty simple. I've got a 3. I've got -8n squared plus 6n squared would be -2n squared plus 6 over 2n squared. And then when I distribute the 3 through, I get -6n squared plus 18 over 2n squared. And I'm going to look at the coefficients in front. And -6 over 2 reduces to -3. And then what do you notice that's unusual about this one compared to, I don't know why it says example 9, because compared to all the other ones, you'll notice that the answer is negative compared to the others. So the answer is negative. So we just got something that was a negative area, okay? And we will talk more about what that looks like a little bit later.